Okay, a little bit more on the world of factoring, solving quadratic equations by factoring. And once we get the idea of how to solve a quadratic equation by factoring, we actually have a little bit more of a challenging exercise, and that's to work backwards. We have two solutions. What could be a quadratic equation that gave us that solution in the first place? So here's an example. We want to write a quadratic equation in standard form that has, and here's one of the requirements, integer exponents. Right, so we only have integer exponents, or coefficients, pardon me, and has 2 and 1/3 as its solutions. So let's think about this situation. If I had x equals 2 as a solution, what would that mean to me? Well, it would mean that I know that I might have had a factor like x minus 2 that I had set equal to 0, and so that it implies that we would have x equals 2 as a possible solution. So sorry, it has the factor quantity x minus 2 as a factor. Now, we also had x equals 1/3 as one of the solutions. But if we say x minus 1/3, the problem that we're going to have right here is that we're not going to get integer coefficients. Why? Well, that would mean that we would have to have x minus 1/3 as one of our factors. And the trouble with that is that, well, 2 times 1/3 is not an integer coefficient, right? We're going to end up with something like 1/3 x. That's no good. We need to back up a little bit here. If I want to get integer solutions, I'm going to have factors with coefficients that are integers. So one way of handling that situation is to say, well, I might have had 3 times x equal to 1 in order to get that factor, which means that 3x minus 1 would equal 0, which in this case implies that the quantity 3x minus 1 would be one of our possible factors. So we think about what this is going to lead to. Well, if we have an equation, then we're going to have an equation that has two factors that we might have solved, x minus 2 times 3x minus 1 equals 0. And then if we want to write the equation in standard form, and standard form means that we have the form ax squared plus bx plus c is equal to 0, we need to do the multiplication right here. So that's going to be 3x squared from our first term. Our outer terms, x times negative 1 is negative x. Our inner terms, negative 2 times 3x is negative 6x. And of course, negative 2 times negative 1 is plus 2 equals 0. And of course, doing that gives us 3x squared minus 7x plus 2 would equal 0. And this is our equation now in standard form. Okay, so if our goal is to find standard form equations that have only integer coefficients, and we have a fraction as a solution, we need to eliminate those fractions in order to do this. So let's try another one. This time we've got 2 zeros, 2 solutions, that is, x equals negative 2/3 is one of those solutions, and x equals 1/6 is the other. All right, so how should this one work out? Well, in this case, when we rewrite our equations, we're going to get rid of those fractions by multiplying both sides by the common denominator. In this case, we're going to get 3x is equal to negative 2. And with our other expression, we're going to multiply times 6 on both sides. So we're going to get 6 times x is equal to 1. And then we're going to add 2 to both sides to set this equal to 0. So we're going to get 3x plus 2 is equal to 0. And here we're going to subtract 1 from both sides to get 6x minus 1 equal to 0. So this is going to give us 2 factors right here. Our factors are going to be the quantities 3x plus 2 and 6x minus 1. We're going to set that equal to 0, and if we're going to put it in standard form, that means we're going to go through and use our FOIL method to multiply things out. 3x times 6x is going to give us 18 times x squared. Our outer terms, negative 3x, 1 times 3x. And our inner terms, 2 times 6x, so that's plus 12x. And for our constant term at the end, positive 2 and negative 1 gives us negative 2 when multiplied. Then simplifying one more time, we should get the equation 18x squared plus 9x minus 2 is equal to 0. So we now have our equation in standard form. Okay, more coming up in the next video.